So students, welcome to the session. So in the last session, we discussed the Leontief input-output model and how we can transform a particular situation in economy or business into the mathematical equations. And now in this session, we will know how we can find out the solution of a mathematical model which is the transformed form of a naturally occurring situation of business or economy. So let us take example 1. So before proceeding the solution of this example, I have taken here again 2 industries first. Then I will take 3 industries in numerical questions. In the first exercise, I have taken 2 industries so that you can understand how the practical utility or how the method works, or you can easily understand the basic concept of finding out the solution of any problem using Leontief input-output model. So what this example refers to, this example says an economy consists of 2 co-dependent industries. So here we are having 2 dependent industries as required by Leontief input-output model. Industries are steel and the second is lumber, right? They are the 2 industries. So what is given here? It takes 0.1 units of steel and 0.5 units of lumber to make each unit of steel. Clear? It takes 0.1 unit of steel and 0.5 units of lumber to make each unit of steel. Means 1 unit of steel is being produced by consuming 0.1 unit of steel and 0.5 units of lumber. Next, it takes 0.2 units of steel and 0 units of lumber to make each unit of lumber. It means 1 unit of lumber is being produced by consuming 0.2 units of steel and 0 units of lumber. The economy will export 16 units of steel and 8 units of lumber next month. This is the final demand which is being exported out of the industries, right? That is D. How many units of steel and lumber will they need to produce to meet this external demand, right? So what is given here? We are given here 2 industries, steel and lumber. In case of steel and lumber operations, we can write 2 equations. See, what is this? These 2 equations. Steel produced. Steel is being produced by what? By consuming some amount of steel itself and some amount of lumber itself. Clear? Then this is the steel for the consumers. What does it mean? There is no industry which runs independently. If in steel industry is producing steel, then some portion of the steel will be consumed by the steel industry itself. So this is what steel for the steel required. Likewise, lumber production. Lumber for steel, how much lumber is required, and lumber for the lumber itself. Lumber need lumber itself for the production of the lumber, and the rest will go outside as a final demand. Clear? Are you getting the objective? Whenever we are producing a steel, steel cannot be produced by only using the commodities of different aspect. We always need some amount of steel needed to produce steel itself. Likewise, some amount of lumber is needed to produce lumber itself. It is very similar to what, say, I am running a firm of manufacturing electricity. If I am producing electricity, it's not possible that whatever electricity I will produce, I will export it to outside my industry. Some amount of electricity which I am producing will be utilized by my firm also. Number one. Number two, I cannot produce electricity independently. I will have to borrow or I will have to purchase some other commodities and services from other industries also. Then I will produce electricity. That is what the situation is here. Steel is itself required to produce the steel. Likewise, lumber is itself is required to produce lumber. That is why I have written these two equations. From these two equations, we will formulate our standard equations. Now let's try to write these equations more mathematically by defining the production of steel and lumber. Now let the production of steel be X. Now we are forming the formal equations, right? The production of steel be X and the production of lumber be Y. Clear? So this is what X is equals to steel required for the steel plus steel required for the lumber plus the demand D1. This will be equation 1. Clear? Likewise, Y is equals to, this is Y, lumber needed for steel plus lumber required for the lumber itself plus the final demand, that is D2. Clear? Should I write these two equations? See how they works. Let xy represents the amount of steel and lumber we are producing. Well, the problem tells us that it takes, what is given there, it takes zero point 0.1 units of steel, it is given in the question, it takes 0.1 unit of steel to produce 1 unit of steel and zero point 0.2 unit of steel to produce 1 unit of lumber. Clear? So, steel needed for the steel, we are using the same thing, Aij, this is equals to what? We use this formula here, Aij is equals to Xij divided by Xj. Steel for steel, 0.1 upon 1 into X. See, A11 will be what? X11 divided by X1. So what is X1? It is given that zero point 0.1 unit of steel required to produce 1 unit of steel. Here X1 is equals to 1 unit, right? And X11 is given as 0.1. Clear? So for 1 unit of production, what is this? A11 will be equals to 0.1 divided by 1. This is what? 0.1, right? 0.1 unit of steel is required to produce 1 unit of steel. But what is the quantity of steel? We are producing X units of steel. So how much we will get? 0.1 must be multiplied by X. Clear? How? If the cost of this pen is 5 rupees, cost of 1 pen is 5 rupees, then cost of 3 pen will be what? 5 into 3, 15. So if 1 unit of steel is required, if 1 unit of steel is being produced by steel itself is coming out to be 0.1, then X unit of steel will be produced by 0.1 into X. This is how we get this equation. Clear? Are you getting the point? By using this formula. A11 is coming out to be 0.1. A11 is what? This is the production of 1 unit of steel. A11 is equals to 1 means zero point 0.1 unit of steel is required to produce 1 unit of steel. So, if we want to produce X units of steel, then 0.1 should be multiplied by X to get 0.1X. Similarly, steel for lumber. What is given? 0.2 units of steel are required to produce 1 unit of lumber. So, 0.2 is divided by 1, you will get here 0.2. This is what? This is 1 unit of steel, 0.2 units of lumber is required to produce 1 unit of steel, 1 unit of lumber. If we want to produce y units of lumber, so this will be 0.2 into y. Are you getting the point? Likewise, lumber for steel, we can form the second equation like this. Clear? Hope you understand this concept. Use this formula to obtain these equations. Right. Let me explain once more for your understanding clear. What is given here? 0.1 upon 1, A11 is 0.1, x1 is 1. 0.1 unit of steel is producing 1 unit of lumber. So 1 unit of steel will produce 0.1 divided by 1. So 0.1 divided by 1, you are getting 0.1. 0.1 is what? This is the input required, means the quantity of steel required to produce 1 unit. But we want to produce x units of steel. So if the cost of 1 unit is 0.1, then the cost of x units will be 0.1 into x. Clear? This is how we are doing this calculation, 0.1x. Similarly, you can find out 0.2 units of steel is required to produce 1 unit. So 0.2 divided by 1, you will get 0.2 divided by 1, you will get 0.2. This is what? 0.2 units of steel is required to produce 1 unit of lumber. So we are producing y units of lumber. So 0.2 should be multiplied by y to get the second term, that is 0.2y. So 0.1x plus 0.2y. Now similarly, the amounts needed for producing steel and lumber. This is steel for lumber, this is lumber for lumber, because no lumber is required for the production of lumber, it is given in the question. So what are these equations? Substituting these expressions along with the external demand. See, x is the total output, this is equals to this plus this. So 0.1x plus 0.2y plus 16 is the external demand, it is given in the question. This is our equation number 1. Similarly, y is the production of lumber, so y is equals to this plus this, and 8 is the final demand. This is also given in the question. Clear? So this is how we get these two equations, and now we can solve these two equations by any one of the two methods, either the Cramer's rule or by the matrix inversion method. It's your choice. Clear? Hope you understand how we obtain these two equations. It's very simple. Use this formula here. It will help you a lot. Very simple. See, it is given that 0.1 unit of steel to produce 1 unit. What we want to calculate? A11 is what? The amount of steel required to produce 1 unit of steel. It is given here 0.1 unit of steel needed to produce 1 unit. So we will divide 0.1 by 1. We will get here 0.1. And what we are doing? We are producing x units. So 0.1 should be multiplied with x to get as 0.1x, right? So these are the two equations. Now find out the solution of these two equations using either the matrix inversion method or by Cramer's rule. See which method we have used here. We can write down these two equations as usual, the right hand side as xy. The matrix of the coefficients of the variable here is what? 0.1, 0.2, 0.5 and 0, right? This is A. If you multiply A with x, that is xy, and add it to D, that is D1 and D2. And this must be equals to what? This must be equals to x. See, this is the same equation. Right? Same thing this here. Put the values of x, d1, d2, you will get this equation. Now, this can be written as x is equals to, as we know, ax plus d, and if you simplify it, we can write it as I minus a of x is equals to d. Clear? We have obtained this Leontief equation. Clear? Now the solution of this equation is equals to this. Oh, we have used here the matrix inversion method, but if you are not comfortable with the matrix inversion method, you are free to use Cramer's rule. I will also explain the Cramer's rule in the next few slides. We know that our equation is I minus a of x is equals to d. This equation will have a unique solution given by x is equals to I minus a inverse into d if I minus a determinant is not equals to 0. This is very similar to ax is equals to b. The difference is what? Here in this equation we are having I minus a in place of a. The rest is as usual. I is what? I is an identity matrix 1, 0, 0, 1, and I minus a means the difference of the identity matrix and the matrix A itself. You will get I minus a, right? So the equation is very much similar to ax is equals to b. So all the conditions which we used for this equation, they will still remain valid for this equation also. So see here, I minus a, we have calculated I is this, the difference of this I minus a, you will get this as a matrix. Now the solution of the system is equals to I minus a inverse of d if determinant of I minus a is not equals to 0. So determinant of I minus a is equals to this. Simplify this, you are getting it as 0.8 and this is not equals to 0. Hence I minus a inverse exists. And we know the formula of A inverse. A inverse is given by adjoint of A divided by A. Here in place of A, what we are having? We are having I minus A. So I minus A inverse will be equals to adjoint of I minus A divided by I minus a of its determinant, right? So we are using the same formula here. Clear? Now the value of the determinant is 0.8. So 1 upon 8, this is the adjoint of the matrix. I have told you many ways to write down the adjoint of a matrix of order 2. The first principal diagonals are flipped and second principal diagonal will be multiplied by minus. So simplifying this, you will get this as a matrix. So this is the inverse of what? I minus a inverse, and the solution is given by x is equals to I minus a inverse into d. So I minus a inverse should be multiplied with the matrix D, that is the final demand 16 and 8. If you multiply these two matrices, the resultant of the product of these two matrices is coming out to be 22 and 19. This is what? This is x and y. This is equals to 22 and 19, right? And by equality of two matrices, x is equals to 22 and y is equals to 19. Clear? So this is how we can determine the values of the output of the two commodities, steel and lumber, so that it should meet the required demand, right? Now I have told you we can find out the solution of the system I minus a of x is equals to d using either the matrix inversion method or by the Cramer's rule. For the sake of understanding or for the convenience of these students, I have also solved the same question by using the Cramer's rule. This is our equations, these are the equations, right? Now this you know same up to here, we don't change anything else. We obtain our equation I minus a of x is equals to d. In both method up to here we will do same. Now after here in matrix method we calculate its inverse, but here we will calculate its determinant. So since the matrix A is this, it is given, right? This is the matrix. So we calculate I minus A and denote it by D as determinant. Its determinant is coming out to be 0.8 as we have calculated in the last slide. Now calculate dx and dy. You know, in Cramer's rule, we calculate dx and dy. Dx is simply obtained by replacing the first column of the determinant by the entries of the right hand side, that is the final demand 16 and 8. So this is our dx and its value is coming out to be 17.6, and you know dy is obtained by replacing the second column of the determinant by the entries of the right hand side, that is 16 and 8. So this is your dy, its value is coming out to be 15.2, and by using the usual formula of the Cramer's rule, x is equals to dx upon d and y is equals to dy upon d. This is y. So x is coming out to be 22 and y is coming out to be 19. So we can get same solution either by using the matrix inversion method or we can use the Cramer's rule, right? Let us take this example. Here in this example, we have taken 3 industries. I have told you in the very beginning, initially I have considered the simplest case so that you can understand it, and I have taken only 2 industries because 2 industries are required as a minimum. So here we have taken 3 industries. See, an economy has 3 sectors, S1, S2 and S3. The Leontief matrix is given by, clear. Here you don't have to formulate the equation, you don't have any need to write down the Leontief matrix. This is another type of question. The Leontief matrix is already given, clear. A11, the first term is A11, A12, A13, like this, right? What you want to calculate? What is the meaning of the entry point 4? See this. This is the matrix, Leontief matrix is given to you. What is the meaning of entry 4, point 4? Point 4 is this entry. Look at this. Point 4 is lying in third row and second column. So it is being represented by third row and second column. What it will represent? This is the entry point 4. What is the meaning of the entry point 4 in the matrix? So look at this matrix very carefully. A32 is equals to 0.4. This is A31, this is A32, right? This is A31, this is A32. So A32 is 0.4, which simply represents what? The number of units consumed by sector S3 necessary to produce 1 unit of sector S2. Clear? This number A32 simply represents the number of units consumed by sector S3 necessary to produce 1 unit by sector S2. Clear? Case 2, assume that the number of output of sector S2 is 200. So number of output of sector S2, say this is sector S1, this is sector S2, this is sector S3, right? Take it like this. So the output of sector S2 means X2 is equals to 200. Let the output of sector 1 is X1, output of sector 2 S2 is X2, output of sector S3 is X3. So X1, X2, X3 represents the output of these 3 sectors. So what is given here? Assume that the total output of the sector S2 is 200. So X2 is given as 200 here. Then what is the number of units produced by sector S3 and consumed by sector S2? So number of units produced by sector S3 and consumed by sector S2 means A32, right? The number of units produced by sector, then the number of units produced by sector S3 and consumed by sector S2. Look at this, what I told you, Xij represents the output of ith industry used as input in jth industry. Xij represents the output of ith industry used as input in jth industry. So A32 will represent the number of units produced by sector S3 and consumed by sector S2, right? So A32, what we want to calculate? We want to calculate then what is the number of units. So we want to calculate A32 into X2. A32 is what? A31 is 0.2, A32 is 0.4. So this is 0.4 into X2 is given as 200. So 200 into 0.4 you will get here as 80. So this is 80 units. Clear? Case 3, if the production level matrix is X, find the internal demand matrix. Internal demand means the demand which is being consumed within the industry, right? And we know that if A is a matrix and if this is multiplied with X, then AX is called internal demand, right? So A is there, X is given here 120, 110, 100. So multiply these two matrices, the product of these two will give you the internal demand matrix that is given by 67, 78 and 98, right? Let us take this example also. An economy has three industries, again I1, I2 and I3. The Leontief matrix is given by this. Here again they have given the Leontief matrix. You don't need to formulate the equations yourself, right? Because the difficult task in Leontief model is what? To transform the word problem to the mathematical equations. So here the matrix is given. Find the total output X1, X2, X3 of the industries I1, I2, I3 if 58, 58 and 62 are externally demanded units of the industries respectively, right? So 58, 58 and 62 units are considered as the final demand, means demand which is needed out of the industries for the consumers. They may be the government, they may be NGOs or they may be individual customers, right? So let X1, X is equals to this X1, X2 and X3 be the total output of three industries I1, I2 and I3. Clear? Then we know that what is the equation? X is equals to AX plus D. This is the Leontief equation and this can be written as I minus A of X is equals to D, right? We are getting this. Now what is I minus A? A is with this, I will be what? I will be an identity matrix 1 0 0 0 1 0 0 0 1. So find out the difference of identity and the matrix this right here. This is an exercise for you. The difference of the identity matrix and the matrix A, this one, right? So you will get this matrix like this. Say 1 minus 0.2, you will get here 0.8. The rest you should do yourself. 0 minus 0.2, you will get here minus 0.2. 0 minus 0.3, you will get here minus 0.3. So likewise, you can take the difference of I minus A to get this matrix. This is the matrix A. X is as usual. This X1, X2, X3. This is the final demand which is given in our question. Now, this is the matrix equation I minus AX is equals to D. Either you can use the matrix inversion method or you can use the Cramer's rule to find out its solution. Here we have used the Cramer's rule, but I will suggest you students please find out its solution by matrix inversion method for the sake of practice, right? Cramer's rule is what? What is the determinant of this? So you know determinant of this is as usual the same 0.8 minus 0.3, 0.1. This is D and if you expand this determinant along any one of the any one of the 3 rows or 3 columns, its value will come out to be 0.331. Now dx, how we obtain dx? We know, as a recap, the first column of D should be replaced by the entries at the right hand side. See, 58, 58, 62. Second and third column will remain as it is. Now simplify this, its value is coming out to be 66.2. Likewise, find out dy. The second column of D should be replaced by the entries at the right hand side. So this is the second column, right? And dz, the third column, should be replaced by the entries at the right hand side. Clear? So this is how you can write down dx dy, and the value of dy is coming out to be this, and the value of dz is coming out to be 72.82. And finally, the total output of the industries I1, I2 and I3 are x1 is equals to dx upon d, it is coming out to be 200. x2 is equals to dy upon d, it is coming out to be 180 units. x3 is equals to dz upon d, it is coming out to be 220 units. So this is how we can determine, means 200 units of the commodity must be produced by industry I1, 180 units must be produced by industry I2, and 220 units must be produced by industry I3, right? So this is how we can determine the solution of any Leontief matrix or Leontief equation by using either the Cramer's rule or by matrix inversion method, right? Now, students, I think I should stop it here and I will continue. Thank you very much.